The percentage of married Americans between the ages of 18 and 64 is given below. By that function, f of t is 76.407 times 0.992 raised to the t, where t is the number of years since 1960 and f of t represents the percentage. We're going to use this model to approximate the year that the percentage hits 40. Since f of t is in percent, then what we need to do is replace f of t by the number 40. Do not put 0.4 because that's not a percentage anymore. You wrote it as a decimal. We need to solve for t. T is currently in the exponent, which makes this an exponential equation. We cannot easily write both sides as the same base, meaning that we need to use this as a logarithm. Just as we had before, if your exponential term has a coefficient other than 1, you have to get rid of it. In this case, we're going to divide both sides by 76.407. Now, 40 divided by 76.407 is not a pretty number. Leave it alone, because if you round this now, it's going to throw off the rest of the problem. All right, so we have an exponential equation that's not one-to-ones. We need to turn this into a logarithm. The base of the exponent is the base of the log, so we can say log base 0.992 of 40 over 76.407 equals t. Now that is an exact value for the purposes of our problem, but we sort of want to get an approximation, just because if you told someone, oh yeah, in log base 0.992 of 40 over 76.407 years, it's when the that's when the percent of married adults will hit 40%. They will look at you weird, despite the fact that that's a crazy sentence to begin with. So let's pull in our calculator here. Now, most modern calculators, you can put this in directly. And the way you would do that is you would go to math, if you have a TI-84, that is. And I think we're looking for log base. There it is, log base. And you can actually type it in exactly how it looks, which is very, very nice. This feature wasn't there back in my day. So we'd say log base 0.992, and I'll just type in 40 divided by 76.407. Boop. So in about 80.6 years, technically after 1960, so 80.6 years after 1960, we could just say during 2040. Don't round that up to 81 because that puts you in the next year. Now, the other way to do this, if you don't have that fancy log base in your calculator, is you can use the change of base rule, which says you would take the log of the argument. Oops, I forgot my... No, I'm good. 76.407. And divide it by the log of the base. So LOG here is the base 10 log. So I can say log of 40 divided by 76.407. Close that off, divided by the log of 0.992. And we get the same answer. So either way is totally fine. Instead of an LOG, you could use a natural log. But previously, we were not able to solve these problems because we didn't know about logarithms, so we had to use the intersect command in the calculator. But now, we know about logarithms, so we can solve for the exponent in an exponential equation.